decision tree. So let's create codes for decision tree. For this, we need two packages, rpart and rpart.plot. So we will be loading multiple packages at once using pacman package under the command p underscore load. So I am loading rpart, rpart.plot, and dplwire for manipulating our data. If you are not, if you want to download these packages, just go to package tab here and install, or you can use the command install.packages. So first we are creating classification tree. So they are created for categorical variables, and it results in qualitative responses. So for this we are using empty cars data set. As we discussed that we need a categorical value. So let's see the structure of empty cars that we are using. You can see there are two variables, VS and AM. So VS is the engine type of the cars and AM is the transmission type of the cars. So they are in the binary form 0 and 1, 0 and 1. So we will be using transmission here, and we will be predicting the type of car, whether it is automatic or manual, based upon MPG. So this is the data set that we have. We are copying it to a new variable df, and I am converting AM to factor or categorical variable, because otherwise it will be taken as continuous or a numeric value and the response will not be correct. So for that we will be converting it to factor value. If you want to check the structure, so the AM has been converted to ordered levels, that is 0 and 1. Now we will be creating a decision tree model. So for that, the function that is used is rpart. Within the brackets, the first is the dependent variable, or the variable that we want to predict. So here it is AM. We are predicting whether our car is automatic or not, or it is manual. Then it is the tilde symbol, or we establish a relationship. So we are saying based upon MPG, predict AM, type of the car, and data that I am using here is DF. Then method is class. So method is the type of decision tree you are creating. So here we are creating a classification tree. For that we are using class. If it have been regression tree, for that we will use ANOVA. So let's execute this command, and I'm saving it in variable dt1. So this is the output of our decision tree. First, let's plot our graph, and then we will discuss about the output of our decision tree. So to plot our graph, the function is rpart.plot. Within the brackets, name of the function that we use, the model that we made. So this is the basic graph that we created. Now we will be adding features to it. So for features, what we can do, first I am taking type. So type is the outlook of a tree. For further, if you want to know about our plots here, so there are different type of features for the graph, wherein there are 5 type of so 0 to 5 numbers, and there are different outlooks of the graph you can use. Then there is extra. Extra means it will display extra information about the nodes. There are 3 types of extra features that you can add, 106, 104 and 100. So 106 is the when there is only a binary response. Then 104 is when there are more than 2 levels, and 100 is for other models. Similarly, there are different features you can check. So let's go ahead. So I'm also adding numbers to my nodes here. For that I'm saying true. Let's execute it. So if I take type 1, you can see split, the condition of the split has been taken above our node, which does not seems correct. So for that I am taking type 2, and extra is equal to 104. So the model will be little open up, and so you can see type 2 is a little better looking model, and numbers has been added to our nodes. So let's compare the output here and the graph that is created. So you can see there are 3 output here, 3 rules that these node that explains the nodes here, and these are the legends for these explanations. So n is the total observations that are used in this analysis. So we have used 32 observations. So there were 32 cars here. Then it is the node number. So first thing is node. So here you can see it is node here. This one, it represents the node. This is the node. Then the split. So split in first node, it is the root node. So in root node, there is no split. There is no condition. So because it is root node, it is telling you that it is the root node. Then there is total number of observations, that is 32. In graph, you can see it is 100%, which means it is the entire population. And they have divided the population into two parts here. You can see 59 and 41%. So how is it has been divided? So let's go ahead. So there is 13 and 0 here, as you can see. So these values are 13 is the loss as explained in legends. Next is the y value, that is 0 here. So what does y 0 here means? And you can see 0 here also. So it explains that there is the majority of the cars here in this data set are of automatic type. So 0 is of for automatic and 1 is for manual. So it tells you the majority of that node. In that node, the majority type of car, so it is 0, which means automatic. Then there is the probability. So first probability is for the majority one, so it is for the automatic. Then there is 0.406, which turned out to be 0.41 here. So it is the probability for manual. So how next? You can see there is next node, that is the node number 2. Then in this node, the condition has been applied, that is MPG less than 19.43. So how they have taken the data here, let's see our data set also, it will be clear then. For that, what I am doing is I am using my deployer package and I am arranging MPG based upon AM. In our output, you can see we have marked a benchmark here that we want first decision node to be taken as our split to be an MPG either less than 19.45 or greater than 19.45. Then there is numbers that has been taken 17. Then there is 2, that is loss, and 0 is the majority part, that is automation. So let's see our data here. So we here you can see the there are only 17 observations taken from this 32 observations, total 32. So here our split was 19.45. So you can see it is up till here 19.2. We have arranged our data, the MPG part based upon AM. So after that, the split came here till 17th observation. And you can see majority are the automatic cars, 0, 0, 0. Only 2 cars are of manual type. So in our output, you can see there are 2 loss and majority type is 0, that is automatic. So 88% or 0.88 is the type of automatic cars, and 0.11 is the manual cars, that is for the 2 here. So you can see in the graph also, if MPG is greater than 19, so if it is yes, so 88% are the type of automatic cars and 0.12 is the type of manual cars. So majority is 0. So 0 has been displayed above the node and at the top of the node, and 53% tells you about the population. Out of 100% population, 53% type of cars has been taken under this split. And also you can see the colors have been different in every stage, in every node. So here the majority has been taken, like 53% has been taken here, and the majority is 88% automatic. So the color intensity is dark here, and here it is light because it is lesser in population and manual. So if the MPG is greater than 19, the no side, that is the right side, it tells that it comes to the third node, which tells you the cars are of manual type. So you can see here also the third node, which tells you MPG greater than 19.45. The observations taken here are 15. So 15 after 17 here, 17th observation. Rest all are taken into third node, wherein the majority are manual cars, only 1, 2, 3, 4. So 4 cars are our loss. So they are of automatic type, majority are manual. So 26%, that is the major 26% they are the manual ones. So it is 0 and 1. So first it is manual. So 26% are manual cars and 73% are automatic manual cars. Sorry, 26% are automatic cars and 73% are manual cars. And star here that denotes that this node is your terminal node, that it is the last node. There is no further division.